I'll try.
Nassim Haramein, thank you.
Thank you so much. Thank you so much. Thank you for having me. Appreciate. It's great to be here. My presentation today is called The Cosmological Constant and the Schwarzschild Proton, the Energy of the Future. And, you know, don't panic. It might sound a little complicated, but we actually are going to do a little math together today. You guys ready? Good, good. It's going to be really, really simple stuff, but it has profound implications. And I think it's really important to understand these math, to understand what they mean a little bit, so that we can have a deeper understanding and a deeper meaning to our more spiritual concepts, such as the concepts that tells us that everything is one. You know, we hear that all the time. If you have a problem with your neighbor nowadays, and you live in Sedona, maybe, so you call your spiritual shaman or your spiritual, advisor, and you're like, what do I do? And then they tell you, stay calm. It's all one. You're one with your neighbor. And you might, understand that at some level, but there's another level that's screaming, how? How is it that we are one? How is it that you and I are part of the same system? How is it that I'm one with this podium and so on? There must be some mechanism. And if we don't understand these mechanisms, then it stays a dogma. It stays a concept, a philosophical concept that we cannot apply directly to our society. So it's crucial that we understand the mechanics of such concepts and that we apply it to our society in terms of engineering, in terms of technology that can make an extraordinary difference in our path of evolution at this time. And that's why the energy of the future. So, and what I mean by energy, I mean many things. That is, not only energy, but the transportation of the future, or capacity to reach the stars, or capacity to expand beyond our horizon. Many things that the speakers before me was talking about are taken in the context of our current capacity, or our current technology, our current capacity to transform and to transcend our difficulties. However, technologies that are here today are based on very specific physics that are rapidly changing. As we heard yesterday night, recent experiments at CERN are showing that the speed of light may not be a limit. So, in order to understand energy, people use that word all the time. And actually, if you look in physics, the concept of energy is not so clear. That is, it's nebulous. It's a concept that's used all the time in our equations to make things even out, to make things work. When work has been done by this system, then the energy is transferred to this system. And then if this system does work, it's transferred back to this system, and so on. And those concepts are called conservation laws, or conservation of energy. So energy and conservation of energy. I'd like to read a few things. These are quotes. They're typical. If you open physics books and you look up energy and conservation laws, you'll find these. And they usually go this way. Energy can be defined as as the capacity to do work. It may exist in a variety of form and may be transformed from one type of energy to another. However, these energy transformations are constrained by a fundamental principle, the conservation of energy principle. Excuse my reading. It's my second language, and I'm highly dyslexic. One way to state this principle is energy can neither be created nor destroyed. Another approach is to say that the total energy of an isolated system remains constant. This is very important because let's take a look at a deeper definition. If a system does not interact with its environment in any way, then certain mechanical properties of the system cannot change. These quantities are said to be conserved, and the conservation laws which result can be considered to be the most fundamental principles of mechanics. In mechanics, examples of conserved quantities are energy, momentum, angular momentum. The conservation laws are exact for an isolated system. And, you know, these are laws that have been in place for some 100 years. And we've been using them everywhere in physics. They are fundamental. Yet, most people ignore or pass over, and children are not shown this when they're taught these laws. Students are never taught to go back and look at it more carefully. There's one, you know, very important concept in these laws that come out every time, and it's the concept of an isolated system. So you have to look up isolated system. And when you do, you can be quite surprised. An isolated system implies a collection of matter which does not interact with the rest of the universe at all. Okay? And as far as we know, there are really no such system. There is no shield against gravity. The electromagnetic force is infinite in range. But in order to focus on basic principle, it is useful to postulate such a system to clarify the nature of physical law. And here I have a bubble, you know. All natural laws are based on something that is not found in nature. You'd think there'd be a problem there. In particular, conservation laws can be presumed to be exact when referring to an isolated system, which we just define as not existing anywhere in nature. So how exact are those laws? So there lies the problem. The idea that things can be isolated, that you can, you know, put something in a box and assume that you can analyze that thing ignoring everything else that's going on in the universe. As if you've isolated that box from the rest of existence. And more, as we advance in our technology and in our physics, we realize that that is just not the case, that that is not actually anything that exists in nature, and this artificial way of analysis does not lead to accurate description of the physics of our universe. So how do we deal with it? In one way, what we have to do is start to get what I call a holistic view of the universe. The whole thing. We got to start with a concept in which we understand the whole structure a little more before we start looking at the part. That is, we got to make a we got to have a clearer picture on how the structure of embedded system exists in our universe before we try to identify what the part may look like. Otherwise, it's similar to like taking a Boeing 747 and breaking it down to the smallest piece, and then giving that piece, which might be very tiny, right, to an engineer and saying to the engineer, okay, what did that piece come out of? Could be problematic. He might come up with like a pink elephant. And so this isolated system is really a problem. Let's look at it in a different way. Let's take a look at it in a geometric way. We can call this an isolated system, right? We have a circle that obviously isolates the space within it from the space outside of it. But is it truly isolated? When we look at this, if we look very closely, let's say this was a dot, a little teeny point, and we look really, really closely, we might start to see discreteness in it. We might start to see structure in it. So in this case, let's make the structure an equilateral triangle. And let's polarize that. And as soon as we did, we got a fundamental recursiveness to the geometry we started it with. We have the same triangles that could produce new horizons, new boundaries, new so-called isolated systems. And in each cases, each of these isolated systems is going to observe the rest of the geometry from its own very perspective. So we could say that every point in here, every new boundary is a new set of information, right? Since it's individually observing the rest of the system from its own very specific perspective, gathering its own very specific information, yet having the same geometry and being part of a larger system, which is the whole of the system. You all following me? So in physics, information can be equivalent to energy. So as each time that I'm making a new division, I could say that the energy of the system is increasing, that there is new information.